was wondering if that's what we're doing.
No, that was from my class last night.
I was like, okay.
No, we're not quite there yet.
Hold on. Some really complex stuff, I'm gonna say. Honestly, algebra is not my strong suit. Just math in general, I hate it. I don't know, it's probably just because I have a reading mind, a literature mind, not like... Never been good at math.
Alright, so last class we were working with fractions, particularly looking at adding fractions, and we were looking at how we can model that on a number line as well. And how we can use the number line to help us better understand that adding of fractions also, to give us a visual for that. So I want to talk about some of the problems we were working on last class. So the very first problem, this is on the back of the first, so we got the packet with the number line on there. It's on the back of the number line there. It says student page B at the top, adding fractions on the number line. So if we have this fraction problem right here, 3/4 plus 1/3 equals. Can we add these two fractions together as they are right now?
No.
No, and why not?
They
We don't have the same denominator.
Very good. To add fractions, and we'll see to subtract fractions as well, you have to have a common denominator. They have to be broken up into the same number of pieces, the same number of parts. Right now, we got one broken up into fourths, one broken up into thirds. They have to be broken up into the same number of pieces or parts. So how can we go about finding a common denominator? Or what might our common denominator be here?
12.
12. And how do you come up with that, Asantu?
I multiply 4 because 4 you can have 12 through 4 and 3 you can multiply 3 by 4 and 4 by 3. So you give it 12.
Yeah, because we're looking for a number that both 4 and 3 can go into, or a number that can be divided by both 4 and 3. Now, sometimes you may be able to kind of quickly realize what the common denominator is, but another thing you can do is you can start listing the factors of 4 and of 3 here. And here's what I mean by that. What is 4 times 1?
4.
4. What about 4 times 2? 8. 4 times 3? 12. And if we list some factors of 3, 3 times 1,
3.
3 times 2,
6.
3 times 3,
9.
and then 3 times 4,
12.
12. So we found a common denominator there. We found that 12 is a factor of both 4 and 3. So that can be our common denominator. So now that we found our common denominator of 12, we know these are going to be into 12ths, we now have to come up with equivalent fractions. Because we can't change the value of this 3/4. We're just breaking it up into more parts. We're breaking it up now into 12ths instead of into fourths there. So what we want to think about is what did we multiply 4 by to get 12?
3.
3. So since we multiplied our denominator by 3 to get to our common denominator, what do we have to do with our numerator as well?
Multiply by 3 as well.
Same thing, multiply it by 3 as well. So what is 3 times 3?
9.
9. So what we've done here is we've come up with an equivalent fraction for 3/4. That 3/4 is equal to, is equivalent, is the same as 9/12. Now to give us just a visual to kind of prove to us that that is true, if we look at our number line over here, if we were trying to show fourths, which one of these number lines are we going to use to represent fourths?
The fourth one.
Which one?
The fourth one.
The fourth one, right? Because it's broken up into 1, 2, 3, 4 equal parts there. So this number line is representing fourths, and if we wanted to show 3/4 on there, it would be right here at this point. That's going to be our 3/4. Because we got 1/4, 2/4, and 3/4. Now you don't have to do this on your number line. This is kind of giving us a visual here. But if I was to take this line I've drawn here, and I was to continue it all the way down, and if we look at our very bottom number line, how many parts is the bottom number line broken up into? The whole is broken up into how many total parts?
12.
12 parts, right? So it's broken up into 12ths. And when I drew my line down here, which of those 12ths did that line go to?
9.
9 12ths, right? It's showing that we have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 12ths. So that's just a visual confirmation that we haven't changed the value of our fraction. That 3/4 is equal to 9 12ths. Those are equivalent fractions. Those are the same. So we haven't changed the value of our fraction. We've just changed the number of parts that it's broken up into. So now we want to do the same thing with our 1/3. What do we multiply 3 by to get 12?
4.
4. So since we're multiplying our denominator by 4, we have to do what with our numerator?
You're the same.
Same thing, multiply by 4 as well. What is 1 times 4?
4.
4. So far, to add these fractions, we've come up with a common denominator, and we've written equivalent fractions using that common denominator there. So we haven't changed the value of either one of our fractions, we've just changed the number of parts or pieces that's broken up into. So now that we have a common denominator, somebody tell me, how do we go about adding these two fractions
We
together?
add 9 plus 4.
Yeah, we add our numerator together, 9 plus 4 gives us what?
13.
13. And then what is our denominator going to be?
12.
12. We keep that common denominator of 12 there because we're still talking about something broken up into 12 pieces. And you can think about it as, you know, a pizza. I got a large pizza broken up into 12 slices. I ate 9 out of those 12 slices. I got another large pizza broken up into 12 slices. I ate 4 out of those 12 slices. that means, you know, I've eaten 13/12 of a pizza. Now this fraction right here, 13/12, who can tell me what type of fraction is that?
It's improper.
It's an improper fraction, and what makes it an improper fraction?
The top is numerator is bigger than denominator.
Very good, the numerator is greater than the denominator. Does that mean that it's more or less than 1 whole? More, right? Anytime we have an improper fraction, we're saying it is more than 1 whole. So we want to usually change that into a, what we call a mixed number, which has a whole number and a fraction. So one way we can think about it is how many 12ths would make up 1 whole? 12 12ths would make up 1 whole, right? So we have 13/12, so we have 1 whole, and then how many 12ths do we have left over?
1.
1 12. So we have 1 and 1 12. You know, if we think about it as the pizza again, if I eat 9 out of 12 slices of one pizza, 4 out of 12 slices of another pizza, I've eaten 1 whole pizza, and then a 1/12 of another pizza there. Now, as far as how we can use the number line to kind of visualize this and model what we've done here, is y'all already told me that the bottom number line is representing the 12ths, or showing the 12ths there. So if we want to put this problem on here, we're saying that we're starting with 3/4 and we're adding 1/3 to it. But we came up with our common denominator of 12ths. So we said that 3/4 equaled how many 12ths?
You say what?
3/4 was equal to how many 12ths?
9/12.
9/12, right? So we could draw our original line starting at 0, 1, 2, 3, 4, 5, 6, 7, 8. I got in the way there. 9. So that's our 9/12. That's our 3/4, which is equal to 9/12 right there. Now, how much are we adding to it? We're adding 1/3, which is equal to how many fourths?
4/12.
Or excuse me, how many 12? Thank you. 4/12. 1, 2, 3, 4. So we've added that on there. That's our 1/3, or our 4/12 there. So when we add all that together, you know, it takes us a length all the way of right there, where I've drawn my green line. So what is our overall length there? If we had 9/12 and we add 4/12 to it, how many holes do we have according to our number line?
13, 12.
We have 1 hole, right? You're right, we have 13/12 total. We have 13/12 total. But if we look at our number line, we have how many holes?
1 hole.
1 hole, and then how much more than a hole do we have? Another 1/12 right there. Another 1/12. So again, the number line is a way to model the problem and to visualize the problem there. Because what we did is we took 3/4, which we came up with an equivalent fraction of 9/12. We added to it 1/3, and we came up with the equivalent fraction 4/12 there. And when we did that, we got a total of 13/12, which is equal to 1 whole and then another 1/12 right there. 1 whole and then another 1/12. So the number line is really a tool to help us model and to understand fraction addition there. So I don't want you to get too bogged down with the number line, if that's throwing you off just a little bit there. I want you to make sure that you're definitely comfortable with finding our common denominator and adding the fractions together there. Any questions on our first one there? And this is from the packet from last class, seriously. Alright, so I want to look at another one together. So this is on just the next page there, student page C. They've given us 2/3 plus, what is it, 2/9? Alright, so first of all, can we add these fractions together as they are?
No.
No, and why not?
Where are you on?
Student page C. So starting from the very front page, we did student page A first, or B first, and then now on student page C. So we got 2/3 plus 2/9 there. As you told me, no, we're not able to add, combine these fractions, add them together as they are. And why are we not able to?
They don't have the same denominator.
They don't have the same denominator, right? We do not have a common denominator. So that's going to have to be our first step to find a common denominator. Now, what might our common denominator be?
9.
9, right? Because 3 can go into 9, and 9 can go into 9. So we can have a common denominator of 9. So now that we have our common denominator, what's our next step in adding these?
Together.
Numerator.
The denominator is the same number that's
Okay, exactly. So we got to go with equivalent fractions, right? We know that 9 is our common denominator. We're breaking both up into 9, but we have to turn this 2/3 into a fraction that is broken up into 9. So what do we multiply 3 by to get 9?
3.
3. So since we're multiplying our denominator by 3, we have to do what with our numerator?
Same.
Multiply it by 3 as well, which 2 times 3 gives us what?
6.
6. Now, for our 2/9, do we have to do anything to that fraction? Do we have to come up with an equivalent fraction?
No.
No, it's already broken up into 9s, right? So we can just, basically bring that fraction over there of 2/9. So now that we have our common denominator, what are we going to get as our answer?
8, 9.
8/9. Because we got 6 plus 2 is 8, so we keep our common denominator of 9 there. Now, is 8/9 more or less than 1 whole?
Less than 1 whole.
Less than 1 whole, right? Because how many 9s would give you 1 whole?
9.
9 9s, right? But we only have 8 9s. So we're close to 1 whole, but we only have 8 9s there. Now just to visualize this one on here as well, which one of our number lines would we use to show adding this together?
7.
And this one right here, right?
Yes.
Yep, that one right there. So we use this one right here. Now, we said that our 2/3 was equal to how many ninths?
2 ninths.
6 ninths, right? So we can draw our first line starting at 0, 1, 2, 3, 4, 5, 6. So we got our 2/3 there, or our 6 ninths, and we're adding a length of how much to it?
2 ninths.
2 ninths, right? So we got 1, 2, 2 ninths. And when we take 2/3 and we add, 2 ninths to it, or we take 6 ninths and we add 2 ninths to it, we got a length of how much?
8 ninths.
8 ninths, right? Which if we look at where we are in our number line, we're at 8 ninths there, right? So we don't have one whole. That one whole is broken up into 9 parts. We have 8 of those 9 parts there. 8 of those 9 parts. Alright, now as far as what the questions were asking you underneath that problem on student page C, they're just asking you which number line will you use to model this problem, which y'all told me which number line, right? It's the one that's broken up into ninths. Now, when it says where is 2/3 on this number line, how do you know? They're asking you where is 2/3 on the number line that you picked. So 2/3 on this number line was at what? 6 ninths, right? That's what they're asking there about that equivalent fraction. What will you do to add the fraction 2 ninths? So to add that fraction 2 ninths, all we really did was extend it by 2 more ninths, right? We didn't have to come up with an equivalent fraction there because 2 ninths we're already using ninths. So we extended our line by 2 ninths. And then how can you read the number line to determine the exact answer? We can read that number line because we know we have less than one whole at our answer. And we know that the whole is broken up into 9 parts and that we have 8 of those ninths there. We have 8 of those ninths. So this is just getting you to look further at, what we're really doing when we come up with that common denominator and those equivalent fractions there. Alright, so any questions so far on the first two we looked at? So I want to look at a couple more to give you a little bit of time to continue working as well. Alright, so if we look on student page D, which is the next page in the packet, they've given us 3/12 plus, 1/6. So somebody tell me what we need to do first. What do we need to do first to find a common denominator, right? We do not have one, so we can't add them together yet. We got to find our common denominator. What is our common denominator going to be?
12.
12, right? Because 12 can go into 12, 6 can go into 12. We have a common denominator of 12. Now, for our first fraction, 3/12, so we have to come up with an equivalent fraction for that?
No.
No, so it's already broken up into 12, right? So we just have our 3/12 here. Now, for 1/6, we need to come up with an equivalent fraction, right? So how do we go about doing that?
Multiply by 2 like you did to get 12.
Exactly. We're saying, what do we multiply 6 by to get 12? We multiply it by 2. So we got to multiply our numerator by 2 as well. Because we can always find an equivalent fraction by multiplying our numerator and denominator by the same number. So if we multiply 1 times 2, we get what? 2. So we have 3/12 plus 2/12. So what's our answer going to be?
5/12.
5/12. Very good. And is that more or less than a whole?
Less.
Less than a whole, right? It's going to be less than a whole there. Now, if you were, and we're not going to show it on the number line here, you already could have done that, but if we were going to use a number line here, it's going to have to be a number line that the whole is broken up into how many parts? 12 parts, right? We're going to use a number line where the whole is broken up into 12 parts. Alright, so one last one to go over together here, the next one on that page. They give us 2/3 plus, what is it? 1/2? 2/3 plus 1/2. Alright, so what's our very first step going to need to be here? Find a common denominator. What can our common denominator be?
6.
6, very good. So after we have our common denominator, what's our next step?
Multiplying the numerator by the same number.
Exactly, coming up with that equivalent fraction, right? So what did we multiply 3 by to get 6?
2.
2. So we got to multiply our numerator by
2.
2. 2 times 2 gives us what? 4. And then we need to come up with an equivalent fraction for the 1/2 as well.
Multiplying by 3.
Multiplying by 3, denominator and numerator. Which means 1/2 equals how many 6?
36.
36. So then when we add these fractions together, 4, 6 plus 3, 6, that equals what?
7.
7, 6. Now this 7, 6, is that more or less than one whole?
More.
More than a whole, right? So how many 6 would make up a whole?
6.
6, 6. So we have one whole, and then we have how many left over?
1.
1 6 left over, right? Because 6 out of 6 gives us one whole. We have 7 6, so we have one whole, and then we have an additional 6 left there as well, an additional 6. Anyway, and if we were to do this one on a number line, we have to use a number line where the whole is broken up into how many parts?
6.
6 parts, right? Where it's broken up into 6. Alright, so what I want you to continue working on is on the next page, student page E. If you haven't done those 2 addition problems yet, go ahead and complete those. And then after that, flip on to student page F, G, and H, the last 3, and you're going to want to complete those as well. Now pay close attention to the last 3. We're looking at subtracting using the number line. So we're looking at subtracting on the last 3 pages there. So I want you to continue working on that. If you finished it up already, I'll come around and check it. But continue working, and if you have any questions, of course, let me know, but I'll come around and check in on you as well. So again, student page E, adding those last 2 there, and then the last 3 pages where you're looking at subtraction now.
Yeah. I think
Now for this, so you came up with the equivalent fraction 4/10, right?
Mm-hmm.
But for this one, what do we multiply the 2 by to get 10?
5.
5, so we got to multiply the 1 by 5 as well, right?
Yeah, that's true. Subtraction, that one.
It's 9/10.
And then for this one, the only thing we need to think about is we don't just have 1/3, we have 1 and 1/3, right? So that means here we really have, 1 and 3/9, right? So your final answer wouldn't just be 5/9, but it would be what?
1, 5/9.
1 and 5/9, right, exactly. We gotta remember about that one hole there as well.
Thank you.
Yep, so nothing's good.
Working with adding fraction. And we're continuing working on that packet from last class, and we're kind of picking up student page E here for the 2/5 plus 1/2. Yes, no, you gotta do. So for adding or subtracting fractions, we always have to have common denominator. So we gotta have them broken up into the same number of pieces before we can combine. So to be able to add these two fractions together, what are we going to need to do first? Exactly. What would our common denominator be? When we think about a common denominator, we have to think about a number that both of our denominators can go into. So, but could 5 go into 2? So if our common denominator can't be one of the two denominators we have to come up with a new denominator that both 5 and 2 could go into. So one thing we can do is we can think about the factors of 5. So what's 5 times 1? 5 times 2. So then we can think of factors of 2. What is 2 times 2? 2 times 3. 2 times 4. And 2 times 5. 10. So 10 could be our common denominator because they're factors of both numbers there. Yep, so that could be our common denominator is 10. But once we have that common denominator, we have to come up with equivalent fractions. So we got to think about what did you multiply 5 by to get that 10. So you got to multiply the numerator by 2 as well. Which 2 times 2 would give us what? 4. So our equivalent fraction is 4/10. And then so for the second one, what did you multiply 2 by to get 10? So you got to multiply the numerator by 5 as well, which would give us what? 5. So you're left with 4/10 plus 5/10. And now that we have a common denominator and equivalent fractions, we can add them together. So if we get the 15/12 there, how could we write that as a mixed number? Wait, hold on. What was that? How did you get to 15 plus? Where'd you get the 27 from? Yeah, so it's 9. Because you're right, that 27 could be.
Yeah.
Now, did you turn this 1 1/3 into a improper fraction, or do you leave it as a mixed number? Okay, so if we're leaving it as a mixed number, what's our fraction here going to be for 1/3 and 9ths? Well, where are you getting 12 from?
9.
But where'd you get the 9 and the 6 from? Well, when I think about what do you multiply 3 by to get this denominator of 9? So you got to multiply the 1 by 3, which would give us what? 3. And then we didn't have to multiply the 9 by anything, right? So we just have the 2 9ths there. So 1 and 5 9ths. Yeah, you can leave it at mixed number. Yeah. The nice one, yep. Yep, and you would take, you're welcome. And you would take, 1 whole plus an additional 3 9ths and then add 2 more 9ths to it. Which way are you going? That's what this one is here. Now, how'd you get the 2 tenths here? Which will be 10, right? But what did you multiply the 2 by to get that 10? Or, well, no, this 2 here, you multiplied by what? To get the denominator of 10. So that means you got to multiply your numerator by what? By 5 as well. So it looks like you multiplied it by just 2. Because remember, to come up with our equivalent fraction, we've got to multiply the numerator and the denominator by the same number. So if you're multiplying this 2 by 5 to get 10, you got to multiply the 1 by 5 to get your numerator. Which 1 by times 5 would give us what? 5. So then when you do 4 tenths plus 5 tenths, we would get what? 9 tenths, exactly. And then so for the next one, you were doing 1 1/3 plus 2 9ths. How'd you get that? 2 1 2/3. Yeah, go back and find your common denominator and look back at that one. Yeah, think about a number that both 3 and 9 can go into. And what we can think about is we can always check to see if one of our 2 denominators could be our common denominator. So will 3 go into 9 evenly? So 9 could be our common denominator then. Keep what the same? Well, no, we have to go in the equivalent fraction, so we got to think about what did we multiply 3 by to get 9? So we got to multiply the numerator by 3 as well. And so what did you get? So 3 9ths, right? Now for this one, it's already out of 9ths, right? So do we have to do anything to that one? No. But now don't forget about the 1 whole there, right? So you have 1 whole and 3 9ths plus 2 9ths. Mm-hmm. See this one, Pat?
That was just like this. I did it right here. I don't know if it's correct.
Why do you think it's not correct?
Because I saw this one here. I was trying to put in a number on the line here.
It's correct though.
And that's the last one.
But this one's correct.
Okay.
Yeah. Because you would use it on the line for tenths, right?
Right.
And what you could do is you would start off at 1 and 8 tenths, so whichever one has the full, you know, all the way to 1 plus 8 more tenths.
Okay.
And then you would take away, or you would go back, you know, where it's 5 tenths. Right, that's good. And then let's see. And think about, can we simplify this 2/8? Is there any number that can go into both 2 and 8?
Divide that.
Say it again.
Like we have to divide this into
Well,
something.
well, think because you want to see if we can simplify this. We want to think about, is there a number we can divide both 2 and 8 by?
I don't know how to simplify.
Okay, so to simplify, what we're trying to do is we're trying to put these in its simplest terms, meaning that if there's any number we can divide both 2 and 8 by, we want to do that.
Same number?
Same number, yes, exactly. So think about, can we divide them both by 2?
Yeah.
Okay, so what would 2 divided by 2 give us?
1.
And what would 8 divided by 2 give us?
4.
4. So you have an answer of 1 and 1 4.
Okay.
Because really what you also could have done is, couldn't we have used 4 as our common denominator?
Okay.
So that's why at the end you always want to make sure you go back and simplify.
Okay.
Yeah, but that one's good there.
Thank you.
You stuck on this one here? Okay. So what are you thinking? What we need to do here?
Make this a regular fraction or something.
Now, we could turn this into an improper fraction, is what you're saying, I think. But we can also leave it as the one whole out there, but just not forget about it. And we could just turn this 1/3 into a fraction with a common denominator of 2/9. So what could a common denominator between 1/3 and 2/9 be?
9.
Say it again.
9.
9, right? And so the only thing is we want to bring this one whole over there as well. So we really have 1 and 3/9 plus 2/9, which would give us an answer of what? Yep, exactly. Yes, sir.
Oh, shit.
Is it all right? I doubted myself.
So this here.
I don't figure out. I'm going to figure out my
Very good. So for these, we're going to be looking at combining positive and negative amounts. So we'll see on these number lines we have positive here. And for this, you can use the number lines can really help you with figuring these out as well.
How do you
Okay. So like how we can use the number line. So like for this one, we ended up breaking, our common denominator was what? 10. So we could go and find the number line when it's broken up into 10 parts, which I think is this one right here. You see we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we got 10 there. So that means, you know, from 0 to 1 is one whole. And then each little line, drawing line starting at 0 going to 4 of those tenths. So you're going to draw that on there. So starting at the 0, and then going up 4 of those tenths. 1, 2, 3, 4. And then we're adding how many tenths to it. Well, you started with 4 tenths, you added how many to it? When you added the half, you added how many tenths to it? Because when we came to the common denominator, it was 2 tenths, right? So the 2 fifths, we changed to what? 4 tenths, right? You started off with what? You added how many? 5 tenths, right? So you can continue with 5 more. At that point, we have less than one whole, right? And how many tenths total do we have there? 9 tenths, exactly. So it's giving us a visual on the number line there, showing us what we have. And so like for this one, you started with 1 and 3/9, right? So you want to find the one that's broken up into 9 parts. I think it'll be the one right above the one you just used. Let's see, so if we start, we got 1, 2, 3. Well, so if you count the lines, you're counting at 1, 2, 3, 4, 5, 6, 7, 8, 9. Because 9 out of 9 gives us the full whole, right? So in this one, we start off with 1 and 1/3, which we said was 1 and how many ninths? Okay, so you can draw your line all the way to the one whole. And then how many more ninths was it? 1 and 3/9, right? Exactly. And then you're adding to that how many ninths? 2 ninths. So the final length of that entire line is how much? Exactly. Yeah, so you started out with 4. This is this one right here, right? And you took away 2, 7, 8, and you got 5, 6, exactly. Perfect. Okay. Okay. And now you're saying our common denominator is going to be 10? Okay. So what did we multiply the 5 by to get 10? So that means we have to do what? Yeah, exactly.
I don't know.
Oh, now remember, we're not adding in this case, we're doing what? Because they're telling us that, you know, that she lives 1 4/5 miles from school. She rode her bike broke down after half a mile, so she had to walk the remainder of the time. So we're looking for how much she had to walk. And then we just want to turn that into a, since it's an improper fraction, we want to turn it into a mixed number. How you doing? Let's see. What's your looking for that one? Let's see what you did here. So you got the 1 3 ninths here, right?
Yeah.
But for this fraction, wasn't it already in ninths? So we didn't have to multiply our numerator or denominator by anything to come up with an equivalent fraction because it was already in 2 ninths right there. So you would just take the 1 3 ninths and add the 2 ninths to it. Because we already had it in a fraction broken up into ninths. So that's exactly. So we started with this one. And this time, is this addition or subtraction? I don't think about. Why do you say addition? So they're saying Addis lives 7/8 of a mile from school. Sander lives 1/4 of a mile from school. We're trying to look who lives farther away and how much farther they live. So we're actually trying to find the difference between the two amounts they live from the school. So we're going to end up being subtracting instead of adding. In this case, if we have 1 and 0 out of 6, that means we just have how much? Because 0/6 would equal what? And think about it, if you eat 0 out of 6 slices, how much pizza have you eaten? 0, right? So it's just really 1 whole. If you do 4/6 minus 4/6, that just cancels out, you know, gives us 0, so you just have 1 whole there. And now here, remember, we're subtracting, not adding. And don't forget about your whole number there, 1 as well. So for this, we're going to be looking at using a number line and now combining positive and negative amounts.
Okay.
So we see our number line now, we're going to have, you know, positive and negative numbers there. Okay. And for this, the number line can really help you out in solving these. Okay.
Zero.
Which one, Young? Okay, so if those are giving you 0, how much are you left with?
1/12. This is 0.
Well, you have that 1 whole, right? So you're saying your fractions gave you 0, but you still have that 1 whole left, right? Well, now you didn't have 1/12, you had 1 whole, correct? Because you're telling me you had 1 whole in 8/12 minus 8/12, so you're left with just the 1 whole there. So you can just write it as 1. Because with your fractions, you had 8/12, you took 8/12 away, you're left with nothing there, but you still had that 1 whole there. Let's see. Now here, if you're using the common denominator of 8s, what did you multiply the 4 by to get 8? Not 1, but how much? 2. So that means you didn't have 3 8s, but you had how many?
Yeah, what did you want to...
Well, if you had 6 8s minus 4 8s, you're going to be left with how many 8s? Okay. And then can we simplify that 2 8s? Is there any number that can go into both 2 and 8?
2.
Okay. So 2 divided by 2 would give us what?
1.
Okay. And 8 divided by 2 would give us what?
4.
Okay. So our fraction, we could simplify 2 8s as what? 1/4. Exactly. Now I think it looks like you did the same thing here, because you didn't multiply 5 times 1 to get 10. What did you multiply 5 times?
2.
So that means you got to multiply. Exactly.
Maybe 3.
And then and don't forget about your whole you had there as well, right? Now for this one, just think about if you could simplify. Hold on, let me see. It's this one here. So what number can we divide both 10 and 16 by? And you can always, if you're not sure, you can always start with 2. Will 2 go into both of those?
Yeah, it does.
So your 10/16 can be simplified as well. You do always want to make sure that we simplify our fractions at the very end of our final answer. And that's always thinking about, is there a number that we can divide the numerator and the denominator both by the same number? So in this here, we're going to be using the number lines, and we're going to be looking at going below 0, so we're going to be combining some positive and negative numbers there. But on this, the number lines can really help us to understand.
How are we doing this in class?
Go ahead and get started on it. We'll talk more about it in a few minutes. But go ahead and take a look at it first. Well, if you think about it, if you're going to use the number line, we still have to think about our common denominator first, right? Which, what would a common denominator for 7 8s and 1/4 be? Okay, so 8 could be our common denominator, right? So we could use our number line here, but you got to use the one where it's broken up into 8 parts. And then you're going to have to come up with, you're going to have to change the 1/4 to where it's out of 8s as well, come up with that equivalent fraction for it. Yeah, I know the copy didn't show up very dark, but yeah, you want to find, once you have your common denominator, you would use that to find what number line you could use. So see, you got 1/4 there. You got what, 1 whole there, very good. Now, how did you get the 6/4 here? But remember, just like when we're adding, when we're subtracting fractions, we have to have a common denominator as well. So remember in this one, or in the previous one, you came up with, oh, I guess this is your first one subtraction, right? But we got to have a common denominator just like we did with the addition as well. So in this, we're going to be looking at combining positive and negative numbers. And just the number line can really help you in solving these. How do you do the 2 there? Think about, so if you start at -1, right, and if you're adding 2 3/4 to it, you're going to go over 1, 2, and then go over 3/4 more. And now for this one, when we're saying we're starting at 2, and they're adding a negative 1 3/4, it means we're going to be moving in the negative direction, 1 3/4. I think you just added a positive 1 3/4, remember, with adding a negative.
No, I went too far. I went to this one. 1/4 and 1/4.
Yeah, so what you want to do is you want to start at whatever you know your first number is, and then based on whatever they're saying you're adding there, you're going to be moving. Well, because if you start at 2 here, right, and you're going that direction 1, you're going 1 and then another 4th, right, is going to put you right there.
It's going to just be 3/4.
Just look back.
Negative 3/4?
Well, are you going positive or negative there?
Negative.
Or are you, is it more or less than 0 though?
Oh, it's 3/4. Hold on.
Okay. So if we think about the 1/4, how many 8ths is that going to be? 2 8ths, right? So if you're telling me that you start at 7 8ths, that Aiden lives 7 8ths away from school, and then we're trying to find the difference here, so if you take away 2 8ths, how many 8ths are you going to be left with? And you can use your number line to do it, right? So you said it's going to be that one that's broken up into 8ths, right? So if you go all the way to 7 8ths, so we got the 7 8ths, and we're taking away how many 8ths from it? You said 1/4 is equal to how many 8ths? Well, how do you know it's 2 8ths? And so 1 times 2 gives us 2, yeah. So you go 7 8ths, and you're taking away 2 8ths from it. You're going to be left with how many 8ths? 5 8ths, exactly. So when we're subtracting, we have to, have a common denominator, just like when we're adding them there. Okay, so what we can do is we can think about, okay, we're taking -1 and we're adding 2 3/4 to it. So we can start here at -1, right? And we're going to be adding 2 wholes and then 3/4 more. So we can start at -1, we can add 1 whole, 2 whole, and then how many more fourths do we need to add? So we need to add 1 2 3/4. So we'd be left right there. Because we started at -1, we added 1 whole, 2 whole to it, and then we added 1 2 3/4 to it there. Because these wholes are already broken up into 4 equal parts. They're all broken up into fourths. So that means what's the value right here? What would our name? Say it again.
Okay, 3/4.
But just 3/4, or do you have a whole as well?
-1 3/4.
Well, now we start.
1
Say it again.
1 3/4.
1 3/4, right? Because we started at -1, we added 2 wholes to it, and then we added 3 more fourths. So we're left with 1 3/4. So for the first one here, how we can use the number line to help us here, is they're telling us -1 plus 2 3/4, right? So if we start here at -1, they're telling us we need to add how much to it? So we're going to add the 2 whole first, 1 2, and then we need to add how many fourths to it? 3/4, so we got 1 2 3/4, which will take us right there to that point. Which what would be the value right there? And just 3/4, or how many holes do you have as well? 1 3/4, right? Because we started off at -1, we added 2 holes to it, 1 2, and then we added 3 more fourths to it, so we have 1 3/4 there. So we think about, if we start here at -1, right, we need to add how much to it? 2 3/4, so we add 1 2, and then we add how many fourths to it? 3. So 1, 2, 3. So we'd be right there. Which would have a value of what? Exactly. 1, 3, 4. What you think about? Well, if you don't have that left, you subtract it, right? It's saying you started at 7/8, and you took away 2/8 from it. So that left you with 5/8 there. So we're subtracting now, we're taking away. Well, if we think about who lived further from school, how far did Aiden live from school? Or Adis, sorry. How many miles did Adis live from school? Well, it tells it, but what does the sentence say? How far away does he live from school? Adis. So Adis lives 7/8 of a mile from school, right? How many eighths of a mile does Xander live from school? What's 1/4? Which you told me was how many eighths? No, you told me that 1/4 was equal to how many eighths? 2/8. So if Adis lives 7/8 from school and Xander lives 2/8 from school, who lives closer to school? Think about which one of those is closer to a whole mile, 7/8 or 2/8? 7/8, right? So Adis almost lives a full mile from school. Xander only lives 2/8 of a mile from school. So it said, who lives farther from school? Which one lives farther? Adis. And how much farther does he live? What did you find was the difference between 7/8 and 1/4? 5/8. He lives 5/8 farther from school. Because Adis lives 7/8 from school, Xander lives 2/8 from school. So how much farther he lives is the 5/8. Let's see, let's do this one. Let's see which one we done. Now, when you get to this 10/16, right, you're trying to simplify that, correct? But if you're simplifying it, you have to divide them both by the same number. So you can divide them both by 2 to simplify, but you can't divide the numerator by 2 and the denominator by 8. You got to divide them both by the same number there. So you're left with an answer of what? 5/8, exactly. Now for G, we need to think about, are we adding or subtracting here? Subtracting, right? Because she has to go. She lives 1 4/5 mile from school. Her bike breaks down after half of a mile. We're looking for how far did she have to walk? How much farther does she still have to go? So you're telling me we're subtracting, but you added them here. Now, but you didn't just have 8/10. You can't forget about your whole number 1 there, right? It's 1 and 8/10 minus 5/10. So you're left with how much? 1 and 3/10, exactly. Oh, okay, so you would use the 1 for tenths, right? Whichever one you have for tenths. And you would start off, Hannah lives how far from school? 1 and how many tenths? 8/10, right? So you would go to 1 and then 8 more tenths. So you start at 1 and 8/10, right? Well, because you got the whole 1, right? You got the whole 1 and 8/10. But how many are you taking away from that? You're taking away half, which was how many tenths? 5/10. So you count back from there 5/10. Well, so you start here, you count back, you go 1. Well, so you're starting here, but this is your first tenth you're taking away. Okay? Which when you get to there, you have 1 whole and how many tenths? Well, you got 1 whole, and then you got 1, 2, 3 tenths. Which is the same as the answer you got, correct? So you did 1 and 3/4. G is the common denominator, 8, you're saying? 6/8. That's 1 and 3/4. Now, when you do that, when you do the 1 minus 1, what do you get? 0, right? So your wholes are canceling out there. But then 6/8 minus 2/8 will give you how much? Or sorry, 6/8 minus 4/8 will give you how much? 2/8, right? And then can you simplify that 2/8? So you get 1/4 there, exactly. And then for this one, you just got an answer of what, 1? Or are you still working on it?
Yeah, still working on it.
Now for this one, how did you get just negative 1, 4? Well, you want to start at negative 2.5, right? Or negative 2.5. Well, where does negative 2.5 start at? Well, if you're talking about right there, that's just a negative half. Because we're going from 0, negative 1, negative 2, so we're moving in this direction with negatives, right? So negative 2.5 is going to be right there. And then you're moving in the negative direction another 1 whole. So you would move 1 whole over from there. Now, you didn't just move 1 whole there, you just moved a half, right? Well, 1 whole is going to be from the middle of that one to the middle of that one. So you move the whole, right? You move 1, 2, 3, 4 fourths, which is the 1 whole. But then you got to move it further. How many fourths? 3 fourths. So right here, you have an answer of negative what? Well, no, negative how many? 4. And then how many more fourths?
1 fourth.
Negative 4 and a fourth there. Because remember, we're moving in the negative direction, you know, numbers are getting further negative there. I think that was one. Alright, so what do we need to do for this one here? Okay, so what can our denominator be if we got 5 and 2 as our current denominator? So we're saying that 5 or 2 can't be our denominator, right? So we're going to come up with a new one. So we need to think of a number that both 5 and 2 can go into. And you can start listing your factors of each one. 10, right? So 10 would work, so we could rewrite these as tenths. So if we do that, what did you multiply the 2 by to get 10? So you got to multiply the 1 by what? Which gives us? Okay, so we got 5 tenths there. What did you multiply the 2 by, or excuse me, the 5 by to get 10? So we got to multiply the 4 by what? 2. 8. So we really have 1 and 8 tenths minus 5 tenths there. Which if we subtract that, what are we going to get as an answer? Exactly, 1 and 3 tenths. So the number line you can use to model it as well. So there's 2 different ways you can think about it. So for the number line, you would go to the one broken up into tenths. You would start off with 1 whole and 8 more tenths, and then you would take 5 tenths away from it. Right. So over here, if we, let's see, so we started off at what number? No, number 1 here. Where do we start off at? At negative 1, right? And we're adding how much to it? Alright, so add your 2 wholes to it first. And then you're adding how much more to it? 3. Alright, so this is your answer right here, not this negative 1. Okay, so that's your answer. Okay, so that was good. So for this one, you're starting at what number? We're starting at 2, right? And we're taking, and we're adding a negative, so we're moving in the negative direction. How much are we taking away from it? Oh, and then in addition, right there. So what would your value right there be? Well, here do you have more or less than a whole? Okay, and this whole is broken up into how many parts? Exactly. What did you get for last one? How do you get 1/3? You were doing this one right here, right? What problem were you doing?
Yes, because I did not put like one number. I didn't put like one.
How do you get that 1/3 then?
I put 2 minus half.
Well, where'd you get half?
I did not add it.
Yeah, so you want to do this problem right here. So think about what is our common denominator going to be.
I don't understand this now.
Okay, so you started off at 2, right?
Mhm.
Now we're taking how much away from it?
Phoenix 1 or
So we're taking away 1 whole,
mm.
and then another fourth right there. Because if we're starting with negative, we're $2, right? Think about starting with 2. We're taking away 1 whole, and then a fourth. So we're going to have this amount right there left over.
Here?
Mm-hmm. Because you took away 1 whole, and then you took away another fourth right there. Because each one of these holes is broken up into 4 parts there. Because you started off at 2, right?
Mm.
And you're adding a negative 1 and a fourth. So we added a negative whole to it, and then took another fourth away there. Because you're not going from 2, and you're not going to the negative 1. You're taking 1 and 1/4 away from it. So you start with 2, you take 1 whole away from it, and then another fourth away from it.
Okay.
Yeah. Yes, ma'am.
So this one is the minus. You can do 1 3/4 or just 3/4.
So you start at a half, right?
Yeah.
And then you took 3/4 away from it? 1, 2, 3.
So this is negative 3/4.
Well, how do you get this as 3/4?
Oh.
Because we're moving back.
Oh, no, 4/4.
Well, no, this right here would be how many fourths? From 0 to that is how many fourths?
1/4.
1/4.
So I'm going to do 1 negative 1/4.
So here you started at, now remember negative 3 and 3/4 is down here. Because we're moving in that direction. This is saying negative 3 and 3 more fourths. You would start right here. And then you're going to add 2 and 3/4 to it.
Mm.
So you're going to add, 2 wholes to it. Alright, so there's one other activity I want us to work on in class. I've given some of you that have finished up an extension. I'm working with looking at some combining positive and negative numbers. We can talk more about that, but I want us to all go to this activity 2 that I'm giving you right here. So we want to talk a little bit about numbers greater than 1. Alright, so this is activity 2. It says greater than 1. So question number 1 says count by fourths until you reach 5. So they started off fourths. They said 1/4, 2/4, 3/4, 4/4, 5/4, 6/4. And they want us to continue going on from there until we reach 5. So if we continue counting by fourths, what's going to come next? 7/4. What about after that? 8/4. Now how do we know when we've reached 5? Because they say count by fourths until you reach 5. How do we know when we've reached 5? What do y'all think? How do we know when we've reached 5? How many fourths would reach 5?
Up to 9?
Say again?
Up to 9/4?
Why do you say 9/4 would be 5?
No, I mean like up to 9 you go like 5.
Well, so they want us to count by fourths, right? So we're counting by fourths. 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4, 9/4, 10/4. You continue on with that. But they want us to continue until we've reached the whole number 5. How will we know when we've reached the whole number 5?
4/4 is
Say, what were you saying?
4/4.
4/4 is what?
So
So 4/4 would be 1 whole, right? So we've reached 1 whole there. How do we know when we've reached the number 5, the whole number 5?
after it's going to be 5, 4.
Well, we're counting by fourths, right? So let's think about when we got to this number 8/4 that y'all told me. How many holes would 8/4 be?
2.
And how do you figure that out?
4. 4. 3.
So 4/4 is 1 hole, right? So if we have 8/4, we have how many holes?
Another hole.
Another hole, right? So we have 2 holes, right? So we're at the hole number 2. So we're going to continue that on until we get to a whole number or until we get to a fraction that equals 5. So you get to one that is equal to the whole number 5. So you would continue on from 8/4, 9/4, 10/4, so on, so on, so on. Keep going on until you have one of the fourths that equals to 5. Now, what they want you to do next, number 2, is which fractions can you simplify? Based on all the fractions that you write, when you go all the way up to 5, which of the ones can you simplify?
2/4.
Number 3, which are less than 1. You're gonna list which of your fractions are less than 1 whole. Number 4, which are equal to 1 whole. Which of your fractions are equal to 1 whole, and which ones are greater than 1, or greater than 1 whole. And what they want you to do is they want you to change those that are greater to whole to a whole number or a mixed number. Like y'all told me 8/4 is equal to how many whole numbers? 8/4 is equal to how many holes? 2 holes, right? 8/4 is 2 holes there. So you would change any of those that are greater to 1 to a whole number or to a mixed number. And by mixed number, we mean you have a whole number and a fraction there. And then number 5, they want you to write a rule for changing a fraction greater than 1 to a combination of a whole and a fraction, a mixed number. So they want you to write out a rule, put in words what you do to change a number or fraction greater than 1 into a mixed number. How do you go about doing that? So for number 1, you're going to continue counting by fourths until you've got to a fraction that equals to 5, equals to the whole number 5. And then you're going to see which ones you can simplify, which ones are less than 1, which is equal to 1 and greater than 1, and they want you to turn all the ones that are greater to 1 into mixed numbers there. Any questions about the directions for this activity here? Alright, so go ahead and get started. So this one's going to stand with
Oh, I don't know.
Oh, okay, so you're just kind of going now. I see what you're doing. Okay. So you're going ahead in the ones that are there. Now, which of these would be equal to those? Okay, here I see. And which ones are less than 1 then? Right, exactly. Now, have you reached all the way to 5 yet? Just think about you going up to what, 12/4? How many holes would 12/4 be? So you want to keep going, right? You haven't reached all the way to 5 yet.
So we're going to simplify all these, or whatever can be simplified?
The one, so they're asking you which fractions can be simplified.
Oh, okay.
And by simplified, they're talking about that you can divide the numerator and the denominator by the same number.
Okay.
They're not talking about turning them into mixed numbers yet, because that's what this one will ask about.
Okay.
So by simplify, they just mean you can divide the numerator and denominator by the same number. So out of these fractions you come up with, you want to think about which ones can you simplify, meaning you can divide the numerator and the denominator by the same number. And then you want to list which of these are less than 1, which one's equal to 1, which are more than 1, and the ones that are more than 1 you want to turn into whole numbers or mixed numbers. Okay, so that. Now, as far as which can you simplify, well, and by simplify, they really mean not necessarily turn it into a mixed number or a whole number. They mean that you can divide the numerator and the denominator by the same one. So what I would do is I would actually look at these mixed numbers you come up with along with these fractions and think about, are there any of these that you could simplify? Where you could divide the numerator and the denominator.
Equal numbers, right?
What do you mean by the equal numbers?
Like the 2 4s and 6s. And 8 4 4s, not the 3s and then 1.
When you think about, so think about what you got here, like 1 and 1/4. Can you simplify 1/4?
No.
What about 1 and 2/4? Can you simplify 2/4?
Yeah.
So that one's good. Yeah. So And so really the only one you're going to be able to simplify is going to be those 2/4. Because it's always going, 1/4, 2/4, 3/4, adding up from there.
So you can only simplify 2/4?
Those are really the only ones. But you would simplify 2/4 as what?
1.
Exactly. And then so down here what they want you to do is they just want you to put in words what your rule is for when you had these improper fractions, how you went about turning them into either a whole or into a mixed number. Like,
And just adding all that, huh?
well, like for this one right here, like put in words, what did you do to get from 5/4 to 1 and 1/4? I'm going to put your rule like in words down there. What do you think?
I don't know how to say it. Can you finish checking out? Because you're adding
Well, think about, imagine you're trying to explain, to somebody else what you're doing.
the whole...
Put it in your own words what you
The
did.
extra? All number plus the extra?
Okay. Yeah, just go back to number 6.
Okay, number 5.
Mm-hmm.
What are the rules of showing manufacturing?
Oh, no, 6, 7. So now really by counting by 1/4, in between all these are numbers too, right?
Right.
So 8/4, 9/4, all the way and so forth there.
Right.
You keep going up by that. Now as far as for which ones you can simplify, by simplify, here they're really talking about that you can divide the numerator and the denominator by the same number. So we think about like 1/4. Could we simplify that? Is there anything that can go into both 1 and 4 besides 1? What about 2/4? Can we simplify that?
Mhm.
What can go into both of those?
2.
So we'd simplify 2/4 as well.
2.
Well, that wouldn't be 2/4, right? If you say 2 over 2, that would be saying 1 whole. So you're saying you could divide them both by 2, right?
Mhm.
So what is 2 divided by 2?
Okay.
And 4 divided by 2. So 2/4 is actually equal to what? To a half. So those would be the ones you could simplify. All the ones that have 2/4 in it, you would be able to simplify.
So I was thinking, we have all these numbers downstairs, so I was thinking what numbers can go into each other.
Right, which for these are really the ones that you can change to a whole number. These are all ones that can go be changed to a whole number. So, here it's asking which fractions can you multiply. Really, any of the ones that have, 2/4 in it, you'll be able to simplify there.
So this will be down here, and then the ones at the top.
But remember, you want to include the numbers that are between there as well.
For these?
Because really it says count by 1/4 until you reach 5, right? So you've done, but you got to 7/8, 8/8, 9/8, 10/8, 11/8, 12/8, and so forth.
Well, that's good because...
But they want you to practice not just turning them into whole numbers, but turning them into mixed numbers as well. And if you skip there, you don't have any to turn into mixed numbers. So what are you doing here to turn it into, kind of explain in words what you're doing to go from that improper fraction to that mixed number. They want you to explain what you're doing there. Now, is 1/4 the only one that's less than 1 whole? What else is? Anything else? Those all are, right? So those are all less than 1. So they're asking, which are less than 1 there. So which are equal to 1? Which of these fractions are equal to 1?
The one that we're going to do here? So those are
But yeah, so 3 is saying which are less than 1. Do you say which one's less than 1? Okay. So which is equal to 1? Which of these fractions is equal to 1 whole?
this one.
Okay. So here it's asking which are equal to 1. So what does that mean about which ones are greater than 1? Which one? Which are greater than 1 whole? Just that one? All of those, right? So all of those are. So what they want you to do is they want you to change those to whole or to mixed numbers. Meaning they want you to rewrite these either as a whole number or as a mixed number where you have the whole number and the fraction. So all those ones that are greater than 1, they want you to change those into whole or mixed numbers. Yeah, so are these the only ones that are greater than 1? And really, so think about for 5/4. How would you go about turning that into a mixed number? Because you're right, you turn these into whole numbers here, but also, how would you turn 5/4 into a mixed number? Think about if you have 5/4, how many wholes do you have? Say it again. 1, and then how much more than 1 whole do you have? 1/4, right? So 5/4 would equal what? Okay. So do that for a few more. I mean, do it for like 6/4, 7/4. Do it for a few more to make sure you're comfortable with going from a whole number, or excuse me, from a improper fraction to a mixed number. And then down here, they just want you to put in words what you're doing. That when you go from a improper fraction to a mixed number, what is your rule? What is it that you're doing? So you got the whole number ones here, right?
Mhm.
But so think about the other ones that are greater than 1. Like is 5/4 greater than 1? 7/4? So turn those then into a mixed number, where you have the whole number and you have a fraction. Because they want you to practice here turning, or be dealing with numbers greater than 1, not only whole numbers, but mixed numbers as well.
Okay.
Okay? And so for here, they want you to write a rule, or they want you to put in words what you do when you are changing an improper fraction to a mixed number. They want you to put it in words. You can go ahead. Number 6, I said to go back.
Oh, that one, right?
Yes, it was number 6 that I needed to go back. The other one.
Oh, then I changed this one because
Whatever you had before, when you asked me to check, it was good. It was only number 6 that you had to go back and look at.
Yes.
No, go ahead and do your thing. Stop asking questions.
What I do is
You done?
yeah, it has this.
Well, I know that. Where he said improper fraction. How did you do that?
This one? It's all these. It's all these you have to do.
Which one?
Okay, so the answer is what you have, plus you have to do all these, the ones after. So 5/4 all the way up
They're
to,
gonna get 1, 2,
yeah, because you see that they go up. You get 1 and 2, 2 and 2.
Say it again.
Well, this is one I'm supposed to write here. Down here.
Okay, yeah.
So like I just instead of rewriting them, I'm just gonna add they don't have to put on this one here.
Well, so you're saying this is 2 and 5/4?
Yeah.
How are you figuring that?
Because this is a 1.
What equals 1 whole? Which fraction equals 1 whole?
4.
4/4, right?
Yes.
So if you have 5/4, how many holes do you have?
2.
How do you figure that you have 2 holes?
Because for that's a whole, because they're asking here, does it count by
Mhm.
1 whole until you reach 5?
Yes. So you're right that 4/4 is 1 whole.
Yes.
But if you have 5/4, how many holes do you have?
1.
You have 1 hole, and then you have a little bit left over, right?
Okay.
Because 4/4 would give you 1 hole. So if you have 5/4, you have 1 hole, and then you have an additional 1/4. You have an extra 1/4 there. And think about if we, where's your number line? Think about in your number line here, right? If you have 5/4, you have 1, 2, 3, 4, 5/4, right? Would be right here. Which means you have how many holes?
1 and half.
You have 1 hole, right? And then how much more?
Half.
How do you, why do you,
Like
A fourth, right? Because these are broken up into fourths. So if you have 5/4, you have 1 whole and then an additional 1/4. You have 1 and 1/4. Because you got 1, 2, 3, 4, 5/4, which gives you the 1 whole and an additional 1/4 right there. So 5/4 as a mixed number would be 1 and 1/4. Alright, so we got one last thing, an exit ticket that we're going to do today. So these are two fraction problems that you are going to solve and that you are going to give to me to check before you leave class today. Now I'm changing the directions a little bit on the strip of paper. We're still going to be solving these two problems, but I'm going to change the directions a little bit on there. So it says estimate and then show by at least 2 ways the solution to these two problems. You don't have to estimate, you only have to show in one way. You have to solve each one of these problems, but you do need to show your work there. So they've given you 3/5 plus 4/6 and 5/8 minus 1/4. So you want to solve both of those two problems on the strip of paper there, and you want to make sure you are showing how you solve the problem. You know, show your work there and show how you solve the problem. So again, you want to solve these two problems and turn it into me for me to check before we leave class in about 8 minutes. This is an exit ticket, so you solve the two problems, and then give it to me, and I will take a look at it. Can you simplify that one in? Yeah, very good. You can go and sign up in there. Can we simplify this one? How'd you get there? What's your next?
I'm going down to the house.
How are you simplifying there? How did you go from this to that? Well, remember, to simplify, we have to divide the numerator and the denominator by the same number. Because if you're a fraction, it's not giving us an equivalent fraction there. So you want to think about, is there a number that we can divide both 8 and 30 by? You're looking for a number that you can divide both 8 and 30 by without a remainder. So think about what you divide 8 by 6. Think first about what are the numbers you can divide 8 by.
2.
Okay, so try that.
Three 15.
How did you get the 3? What's 8 divided by 2?
Oh, 4.
Okay. So, now, so you got 18 30ths plus 20 30ths, right? Which just gave you an answer of what here? Well, now 18 plus 20 would give us what? And then see if you can simplify this one too.
Is this by division or is it fraction?
So it's saying 3/5 plus 4/6. You're doing 3/5 plus 4/6. You're adding those two fractions together. So what you got here?
I can't find a common denominator.
Well, let's think about what are some factors of 5.
I did that and I couldn't find.
So let's think about what is 5 times 6. Yep, very good.
3.
Say it again.
30.
Okay, so what would 6 times 5 be then?
30.
Okay, so that could be your common denominator. So what's our first step going to have to be to add these together? Exactly. Yeah, so that one's good. Now for this one, we got to find a common denominator. Can 5 go into 12?
No, but what I did was, I thought I was going to have either 3 and 4.
But remember, it's 3/5 and 4/6, right? We're looking for a common denominator, not the numerator. But 5 wouldn't go into 12, right? Yeah, so you're good on that one. Alright, so if you didn't finish up the exit ticket, I do want you to take that home and finish it up and bring it back to me to class on Tuesday so I can take a look at that. Because, if you're able to answer that, you've shown, some good mastery of adding and subtracting fractions. But don't forget, our very first step for adding and subtracting fractions is doing what? Finding a common denominator, right? And then coming up with our equivalent fractions there. So if you didn't finish up that exit ticket in class, do finish it up and bring it back to me on Monday or Tuesday, so we can take a look at that. So you go ahead and sign out for 10:30. And then make sure you're next door in the screens class at 10:35. And have a good rest of your day, week, and weekend, and I will see everybody on Tuesday. There we go.
My shirt? Oh, my cup, yeah. Mom is wherever Mama is. That's my son. Are you good? How are the holidays? Okay. See you later. Okay. We'll give everybody a few minutes to get in. Oh, okay.
I'll give them back to you next week. Okay. Methods you use have, just some arguments to define it, like paragraphs, because I'm going to start practicing typing in the font and
I don't right now. I don't have any.
Okay.
Because we would start doing that towards the end of the quarter.
What do you have to find some?
You can really find some on DD.com.
Oh, they have like the arguments and classes? And it's not a text, it's like...
No, it's just practice.
And let's say, the vouchers, I forgot about that.
I have your vouchers, so. You need to bring something. No, can't go. There's nothing.
How's math class?
You look stressed out. Was math a stressful day? Not really. Sometimes it's just overwhelming, like, I don't know, I don't know. I can always tell when you guys have, like, hard math. Everybody looks stressed. It wasn't hard, but the second grade, my brain just shut down, like, I don't know, I can't even think anymore.
Critical thinking is required in this class. It's reading.
Is that critical thinking in which class?
It's required in this class. It's reading.
Yeah. Well, I'd rather have math in the morning than, than in the morning.
Which isn't really a problem for me because I read really tough literature all the time and write essays about it, so, fun. I mean that it's really fun. I go for it. I enjoy it a lot.
Is Miss Teresa here? Yeah, she was in.
I need to wake up. I'm getting tired. Then again, I did only get 3 hours sleep, so it makes sense. I tried to sleep 7 hours, but I just couldn't get to sleep.
Are you feeling better?
Yeah, a little bit.
Alright.
More of this stuff.
So today we're going to get more into the specifics of manufacturing and the actual jobs that they provide. We'll give everybody like 5 more minutes to get break, and then we'll get started. So y'all take a little bit extra time, and then we'll get started. Those of you that want to take your practice test next week?
Yes.
You can take them at home. The only thing is you won't be able to get the scholarship, or if you make over a certain amount, you won't be able to get a scholarship considered at home.
Gotcha.
So that's why I'm asking you to take it here.
I'll take it.
Hello, how are you? So we can go ahead and get started in reading about manufacturing jobs. Is the door locked? I did it. Oh. Lock her out. Alright, so let's get started. Jobs at all skill levels make up the manufacturing career cluster. You might find yourself working on an auto
at an auto plant assembling cars, or you might work in a lab. Do you repeat after I notarize it?
I went ahead and signed it, so just, as long as you trust that I signed it, I trust that you notarized it. Excuse me, guys.
Assembling cars, or you might work in a lab creating robots. Here are some common industry jobs and the skills they require. Somebody read about the tool and die makers under production.
The tool and die maker produces tools, die of special sizing and road devices. These products that the machine mass produce make better parts. Some of the most skilled production workers and manufacturing work in this way. Dies are used to create everything from washing machine parts to TVs. Tools and die makers are employed in nearly all areas of manufacturing. They work in the automotive, aircraft, construction, and some machinery industry. Special skills. According to an attention to detail are essential in making tools and dies. Workers in this career need mechanical ability, mathematical knowledge, and the ability to work well with their hands. They must be able to read distance. They must also be familiar with various production materials, including metals and alloys.
Alright, somebody read welder, cutter, and welder fitter. Welding is a metal part. Welders spend most of their days working with metal. Most welders work for companies that manufacture industrial machinery and equipment for metal products. To perform work, supervise welding safely. Workers need to wear special shoes, goggles, clothes with protective lenses, and other safety equipment. As technology advances, they agree to never unload new tasks are performed using automation or robots. Special skills. Welders must also weld materials that are in operations. For this reason, they must be able to perform tasks lying on their back or while standing high above the ground. Welding that is performed manually requires technical equipment. To plan their work, welders must be able to read drawings, blueprints, and specifications. They must also be able to select the right tools, devise procedures, and inspect their finished products. Welders also need skills such as good mirror vision, precise control of arms, and gestures. Okay, so manufacturing production process development. Manufacturing production technician. A manufacturing production technician sets up, tests, and adjusts machinery and equipment. Production technicians need to be able to adjust machinery to ensure that it creates a high quality product. Technicians might use tools such as calipers, micrometers, and protractors, and brain gauges. Technicians also troubleshoot problems with equipment or products. At the end of the production process, they inspect the product to make sure it meets customers' needs. Special skills. Manufacturing production technicians need specialized knowledge in a number of areas. For example, they need to understand machines and tools thoroughly. This may include machine design, uses, repair, and maintenance. They must have good mathematical skills as well as knowledge of design techniques. They also need good problem-solving skills in order to find effective ways to fix and adjust machines. Somebody read robotics engineer.
Robotics engineering is behind some of today's most dynamic and innovative manufacturing projects. Advances are constantly transforming this career. Robotics engineers are employed in a variety of industries. Some engineers design robots for use in outer space or on the ocean floor. Others automate production lines for aircraft manufacturers. In addition to developing air robots, robotics engineers maintain existing robots and develop new applications for them. Special skills. Robotics engineers spend much of their time conducting trials and research. This career requires creativity and research skills. Sometimes it takes years of research and labor to create a new robot automated system. Engineers must have extensive training and a thorough grasp of mathematics and mechanics. They must have the patience and follow-through to work in complicated projects. Many companies develop robotics at laboratories that are used primarily for research and development. A lab engineer must maintain and service hardware and software. She or he may demonstrate automation and robotic capabilities. Finally, lab engineers are often plan, execute, and document lab experiments.
Alright? Maintenance, installation, repair, medical equipment repair. Someone read that to you.
Medical equipment repairs maintain, adjust, and repair equipment used in hospital and other healthcare settings. They may work on patients, monitors, X-ray machines, electric wheelchair, and other devices. These workers use a wide range of equipment to their work. Often they use specialized software and computers. They may also hand tools, soldering irons, and other electrical tools. Medical equipment repairers work during the day, but they may be on call during all hours. There may be emergency in which repairs are urgently needed. They may need to travel long distance for repair jobs. They must also be willing to work in a mechanical environment which can pose health risks. Special skills. Workers in the field must be willing to work under pressure. They should be able to work well with their hands and have good technical skills. They must be able to quickly identify a problem and find a solution.
They may also need a degree in biomedical technology or engineering.
Alright, so I read general maintenance and repair worker.
General maintenance and repair workers take care of fixed machines, mechanical equipment, and buildings. Their responsibility is varied widely. They might work pipe fixing, welding, and carpentry. They may repair boilers, machines, for electronical or mechanical equipment. Some of their work may be as simple as unplugging drains or repairing electrical switches. Maintenance and repair workers inspect equipment, identify problems, and decide on the best way to fix them. They use hand tools such as screwdrivers and drills, as well as more specialized equipment. Special skills. General maintenance and repair workers should be good with their hands and have good math skills. Since the job requires turning, lifting, and planting, no physical condition is important. These workers should also be problem-solvers and work with students who
Alright, quality assurance. Inspector, tester, sorter, and sampler, and where. These workers, also known as quality control inspectors, inspect a variety of manufactured products, from foods to clothing to cars. They make sure products meet minimum quality standards. They ensure that food is safe to eat, cars are safe to drive, and that other products are made properly. These workers may check products by sight, sound, feel, smell, or taste. They may conduct tests to make sure mechanical products will not break down in the real world. Quality control inspectors work at many stages of the production line. They may test the material that will be used to assemble a product. They may also give a final check after production is completed. They may use sensitive gauges, meters, and other tools to inspect the product. Special skills. Quality control inspectors should have good mechanical skills, math skills, communication skills, hand-eye coordination, and vision. They may need to be able to interpret blueprints, data, and manuals. In many cases, a high school diploma is enough to begin work in the field, and workers are trained on the job. Alright, so I'm going to read quality control system manager.
Quality control system managers are responsible for planning, directing, and coordinating quality assurance programs. To develop quality control policies and make sure the product prepared meets the quality control standards. They may test products and test and also in a single and fixed product. After a test is run, they may analyze test results and share them with the product managers for test. Quality control system managers will also work with sales and marketing to learn more about quality control marketing. Special skills. As managers, these workers must have some communication skills. They should be able to support their employees and motivate them to engage at high levels. They will also be willing to make quick and make important decisions. Quality control system managers should invest early and further real-world problems.
Logistics and inventory control, shipping, receiving, and traffic clerk. Employees in the shipping, receiving, and traffic track incoming and outgoing shipments. Their duties include preparing items for shipment. They assemble goods and address and stamp merchandise. They also unpack and verify incoming merchandise or materials. Shipping, receiving, and traffic clerks are involved on a daily basis with the transportation of products. Important tasks include preparing documents such as orders and shipping orders. Work orders and shipping orders, Clerks must make sure that the shipping materials are in stock. When products are damaged or missing or do not meet specifications, clerks work with the company representatives to fix the problem. For their various tasks, workers use tools ranging from barcode reader equipment to hand trucks. Special skills. Shipping, receiving, and traffic clerks need to be attentive to details, possess good people skills such as active listening and problem sensitivity. They also need to communicate well both verbally and written with supervisors, peers, and subordinates. Alright, cargo and freight agent. I'm going to read that, please.
Cargo and freight agents organize the movement of cargo and freight shipments, which are used for commercial purposes. These guys will receive shipments from airlines, rail, and traffic terminals, as well as shipping logs. Agents take orders from customers and arrange the pickup and delivery of freight. They also prepare and examine the documents to determine shipping charges, tariffs, or taxes. Cargo and freight agents also pass this to shipping. Special skills. Cargo and freight agents need detailed knowledge of the transportation industry. The business of moving people is moved by air, rail, sea, or wind. The more detailed communication skills and help and be able to provide excellent customer service. It is helpful for agents to know one or more foreign languages, as well as we have a good financial knowledge. Agents should have good critical thinking skills, reading logic and identify the strengths and weaknesses of possible solutions to problems.
Health, safety, and environmental assurance. Industrial safety and health engineers. Safety and health engineers plan, carry out, and coordinate safety programs in the manufacturing industry. They use engineering principles and technology to prevent or correct unsafe workplace conditions. These employees often inspect machinery to identify potential hazards. They install safety devices on machines. They report and review findings from accident investigations. They also review employee safety programs to make sure workers are safe. Special skills. Safety and health engineers need a detailed knowledge of specific areas of law, chemistry, engineering, and design. They also need effective communication skills. Finally, they need problem sensitivity. This is the ability to tell whether something is wrong or is likely to go wrong. Environmental compliance inspector. Compliance inspectors investigate sources of pollution to protect the public and the environment. They ensure that companies follow federal, state, and local regulations. They determine code violations. They also examine permits, licenses, applications, and records to ensure companies meet licensing requirements. Special skills. Environment compliance inspectors often need to work with specialized tools, including hydrocarbon analyzers, sampling pumps, soil core sampling apparatuses. They need familiarity with analytical and scientific software. They also need an extensive knowledge of laws, court procedures, and government regulations. Environmental engineer. Environmental engineers look for solutions to environmental problems. They might work to solve air pollution, recycling, waste disposal, or public health issues. These engineers study hazardous waste, its effect on the public, and how to lessen the problem. They may design water supply and wastewater treatment systems. Many work as consultants, helping clients comply or adapt to regulations and minimize damage to the environment. Special skills. An environmental engineer should have a bachelor's degree or higher in the field. A wide range of math and science skills is essential. Environmental engineers should also be creative, analytical, and detail-oriented. Okay? So this chapter gave us a more in-depth look at the jobs that are actually offered for manufacturing. So it's not just working in a factory on an assembly line. There's inspectors, there's clerks. There are people that do the packing. There's people that have to create the work orders, the shipping slips. So there's a large range of different things that go into manufacturing. Health and safety engineers. These are people that make sure that there is actually like an auto shutdown button on devices that we use. If you ever see big machinery, there is a safety button that they can push. Not only that, these people also need to be very familiar with design. This may not be a 2022 design, but it's a 2012 and only a couple parts have changed. So they're still able to figure out how to fix and maneuver those different equipment. So this gave you guys a better understanding of what manufacturing actually offers. So there is probably an administrative job or a clerical job that you can get in the manufacturing field. Okay? So today in language arts, we're going to talk about... I shouldn't eat that popcorn, now I'm driving. Using examples to explain meaning. You got them already?
Sounds like pretty basic English again.
So the vocabulary that we're going to use today are direct, inference, and detail. So when we use detail to explain meaning, in the lesson, you're going to learn how to use detail and explain in examples of literary and informational text. Your first task is to fully understand the text. Then you can use detail to make inferences. Learn the skill. Sometimes you read information, sometimes you find information. Imagine you've been hired at a new job. The company has given you an employee handbook. You will likely want to know details about dress code, company holidays, and sick days, along with other things. You can read the handbook to find specific detailed information about all of those things and more. But some details may not be directly stated in the handbook. You may need to ask your manager about certain policies. You may also need to make inferences about what is expected of you. So what is an inference?
It's when you infer something based on what you read.
Yes, so you're inferring something, you're almost making a guess based on what you've read. You may also need to make, for example, the handbook may state directly that Friday's dress code is casual. But you may notice that some of your coworkers dress formally every day of the week. You might infer that these coworkers are trying to make a good impression on their boss. When you read anything from a newspaper article to a summer beach novel, you are making sense of the written words. When you understand the meaning of a text, you can understand other things that are not directly stated. A reader makes an inference by using details from the text to point out something not in the text. With practice, you will learn to find details that best support and explain ideas in the text, as well as ideas pointed to by the text. Let's look at some examples. Okay?
Oh, J.K. Chesterton.
Huh?
He's a good author.
So, example 1, this is a literary text. So we're going to read the following passage adapted from The Innocence of Father Brown. It's a 19th century detective novel. So we're going to look at the details that are stated directly. We're going to use these details to make inferences. So who wants to read the excerpt that we have?
Valentino Cobb was chief of police. He had a sprawling home, as peculiar and celebrated as the man himself. It was an old house, with high walls and tall trees overhanging the river. The strangest thing about it was that the only exit was to the front door. The garden was large and elaborate. There were many exits from the house into the garden, but there was no exit from the garden to the road outside. All along this garden ran a tall, smooth, unscalable wall with spikes at the top. A bad garden, perhaps, for a man to reflect in. especially a man some 100 criminals sworn to kill.
Okay? In fiction, details are used to describe a setting. The author describes the garden as large and elaborate, with spikes at the top of its surrounding walls. Descriptions of settings allow the reader to imagine a very specific place. It also sets the mood. In many detective stories, the details tell you that the crime or mystery are coming. And because some 100 criminals had sworn to kill the chief of police, you can infer that the chief is good at his job. Okay? Example number 2. This is details in an informational text. Okay, we're going to read the following passage about the National Park Service, the NPS. Look at the details and examples listed in the text. Make inferences about why the National Park Service is important. All right, somebody read about NPS. Okay? So informational texts are often thick with detail. It can be difficult to keep the details organized in your mind. The text above defines an asset and then lists a number of examples. And you can infer that the National Park Service is important to keep the park in good condition. As a reader, make sure you can identify important definitions and examples. The text doesn't change, so you can always go back to review what you read and make sure that you have the details right. Then make the correct inference. So have you ever been reading either science or social studies and you have all this information? Sometimes we forget information or we transpose dates and things like that. So whenever you are making an inference based off an informative text, make sure you go back to check those details to make sure that you are actually drawing the correct conclusion, okay? Alrighty, so guided practice. You're going to read the following passage about Judy Garland. Pay close attention to the details. So somebody read about Judy Garland for us.
Judy Garland was born in June in 1900. She appeared in 10 other movies.
Page 16.
After being made popular, Garland's challenge received a critical set in 1930 for outstanding performance. One of these performances was a Dorothy in the Wizard of Oz 1939. The Smithsonian is home of three famous movies, Sleepers War in the movie. 1939 recording of Over the Rainbow, reached number 5 on the Billboard chart. It became a signature song. She died on June 22, 1969.
Okay? So in what year did Judy Garland win an Oscar?
1940.
1940, she won her Oscar. Alright, and which detail supports the inference that Judy Garland was a talented singer?
Over the Rainbow was 5th on the
Yes,
chart.
5th on the Billboard chart, Over the Rainbow. Okay? Alright, so if you look on the back, we have an independent practice. You are going to read the passage and you're going to answer the questions 3 through 6. And then after you finish that, I want you to do the lesson review. The lesson review is everything we've been doing today. You're looking for specific details and examples to explain directly stated literary or informative text, okay? So go ahead and start with your independent practice and finish with your lesson review. Rule number 3, I'm sorry. What specific details in the text tell you something about the weather?
The sign was soggy and then he avoided getting splashed with the water.
Yes. So the sign was soggy and he avoided being splashed. And he stepped over a puddle in the street. Yes, and he stepped over a puddle in the street. Yep. So based on the details you found, what inference can you make about the weather the night before?
It rained.
Yes, heavy rain or rain. Number 5, based on the details from paragraph 3, which of the following best describes cars Ronald filled and Barris?
C.
C, he does not get dressed for work. And number 6, based on the details from the passage, which is the best inference you can make about the man heading to his Chevy Malibu?
A.
B, he's a friendly neighbor. Well, yeah. Alright, so your lesson review, number 7. According to the passage, which of the following reasons, which of the following is a reason to continue using pennies?
D.
D. Pennies eliminate the need to round prices. Number 8. Which of the following inferences is best supported by the details in the passage?
A.
A. Experts disagree about the economy's impact eliminating pennies. And number 9. Based on the passage, how do you know that personnel on the American military bases have gotten used to rounding prices?
C.
B. Pennies hasn't been used on American bases for 30 years. Number 4. Number 4 was it's raining. It rained or heavy rain. Alrighty.
Oh boy, economics.
Talk about money. So speaking of money and pennies, we're going to talk about economy. So this quarter of social studies will be about economy. And that's dealing with money, right? Dealing with everything that makes the world go around, so they say. So.
It doesn't though.
Huh?
It really doesn't though.
It really doesn't, but unfortunately, those in higher places believe it does. So we are stuck in a vicious cycle of money is everything. Which I'm with you. I don't think that money is everything. So like if we find a different system, things could be better. So, in the modern world, the modern world revolves around economics and the economic system. Thousands of years ago, people produced what they needed on their farms. Slowly, as communities grew, people began to specialize and barter and trade for what they needed. Eventually, currency was used. Livestock and mollusk shells were used as currency in the past. About 1000 BC, the first metal money and coins came into use. Today's economy connects the entire world like never before. The food and the clothes you buy may come from countries around the world. A particularly cold winter in Florida may mean the prices of orange juice skyrocket. We are all connected economically. Right? So economics is the study of what we produce, what we consume, and how we exchange money to get what we need and want. Have you purchased a good or a service in the last week? How did you decide what to purchase, when to purchase it, and how much were you willing to pay for it? So if you went to the gas station, you bought a service, you bought a good. If you went to Kroger, Publix, Piggly Wiggly, Target, Walmart, you bought a good or a service this week. Alright? So who bought a good or service this week?
Well, yesterday after a month that we have that, we went and got Dunkin' Donuts.
Okay, you went and got Dunkin' Donuts. Why did you guys do Dunkin' Donuts?
We were hungry.
You were hungry. Exactly, so I was hungry. And the price you all paid for your Dunkin' Donuts, were you willing to pay more or less for those Dunkin' Donuts?
It was $5.35.
That was reasonable? Okay, reasonable price. So let's say you were buying a car. Bigger price, right? Bigger purchase. So we want to know why you decided to make that purchase. My other car broke down. I needed a second car. Or I just wanted a new car. Alright? When to purchase it? Is it better to purchase it on Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, or Sunday? Sometimes, depending on the market, depends on the best day to buy a car. Prices go up and down on vehicles every day. Alright? So how much are you willing to spend on a car? What are one of the things you look at when you're getting ready to buy a car? Because you know you have a car note unless you have cash. Was it insurance? Insurance is one, depending on what car you have, depends on your insurance. If you get a Charger or any type of Dodge, your insurance is at least going to go up almost $200. Yes, the mileage is also in the age of the car. Yes, monthly payment. So the first thing I'm going to look at when I was getting ready to buy a car is how much do I make, the bills that I pay, and is adding this bill going to be a hardship? So if I know after I pay all my bills, I have about $1,500 just sitting there, I can play a little bit with a new car, you know. I can put 5 towards the car. That's okay. I still have $1,000 to play with, right? So if you think about it, you weigh out your options based on what is economically appropriate for you. Now, there are some people that are going to go out here and buy cars in cash, and that is amazing. That means that they're in a completely different economic tax bracket than I am. Because if you have $20,000 to $30,000 or more in cash that you can actually go get out of your bank, we are in 2 different classes, and I'm okay with that. You do your thing. We are in 2 separate classes. So again, economics is huge when we talk about our lifestyle, how we're going to take things back, and how we contribute back to society. So today, our reading strategy is going to be using primary sources. So primary source includes things such as a diary, speeches, letters, interviews, poems, novels, and art. A primary source gives you a direct view of a particular event or an opinion. In contrast, a secondary source, such as this book, interprets and analyzes a primary source. Read the 2 quotations on page 180 and answer the question. So turn to page 180. Someone read the first one by philosopher Ayn Rand. Huh? Alright, so somebody read the first quotation by the philosopher.
That one?
Yes, Americans Abundance.
Americans Abundance was created not by public exercising to the common good, but by the productive union of free men who pursue their own personal interests and the making of their own private fortune. They did not starve the people to pay for America's industrialization. They gave the people better jobs, higher wages, and cheaper goods with every new machine they invented, with every scientific discovery or technological event, and thus the whole country was moving forward and profiting, not suffering every step of the way. Philosopher Ayn Rand?
Yes. Alright, so that's how the philosopher felt about it. So someone read the United States Senator, Elizabeth Warren. How did she feel about it? Alright, so she says there is nobody in this country who got rich on their own. Nobody. You built a factory out there, good for you. But I want to be clear. You moved your goods to markets and roads the rest of us paid for. You hired workers the rest of us paid to educate. You were safe in your factory because of the police forces and fire forces that the rest of us paid for. You didn't have to worry about motoring bands would come and seize everything at your factory. Now look, you built a factory and it turned out into something terrific or a great idea. God bless. Keep a hunk of it. But part of the underlying social contract is you take a hunk of it and pay it forward to the next kid who comes along. Alright? So, those 2 quotations, what are they mainly talking about?
People making their own money.
How people are making their own money. So basically they're talking about how profit should be viewed, right?
Elizabeth Warren and Rand are so opposite, though.
They're completely opposite, right? So, speaking of that, Senator Warren, what does she think? What was her opinion about Americans' wealth?
She thinks that everyone deserves some.
Yes, she believes that everyone deserves a piece of the pie, right?
Whereas Ayn Rand is like, oh, you should only earn your own stuff and that you shouldn't give it to anyone else because people that do that are weak or something.
Yes, that is her opinion. Absolutely. No, you're spot on. So, Warren's opinion is that if I have a piece of the pie, I need to share it with everybody. Because your tax dollars help me to be able to have a factory. You keep me safe and all these other things. So she's more thinking of it as a overall contribution made to society through taxes, so businesses should give back some of their profit to help others. Okay?
To be fair, there's flaws in both of these points of view.
Exactly. Alright. So the fundamentals of economics on page 170. Economics can be divided into 2 types. Microeconomics and macroeconomics. Who knows the difference between micro and macro? Micro is small and macro is big. Absolutely. So microeconomics is part of the economics that deals with single factors that affect the individual decisions. It explores the interactions between buyers and sellers. Macroeconomics is the part of the economics that deals with the big picture. It explores the economy of the entire country. That's what you're reading. On 179 at the top. I'm sorry, at the top of page 179. Yes.
Oh, okay.
I am, where am I? I think I'm on the fourth page for them. It explores the economy of the entire country, such as the United States. People that study macroeconomics are able to interpret economic indicators to determine how well the economy is doing. Incentives. People make economic decisions every day. Today alone, you likely decide what to eat for breakfast, what clothes to wear, and what toothpaste to use. These decisions are all linked to the economy. So, how do people make these decisions? People make these decisions based on incentives. An incentive is something that influences behavior. You might work extra hours at your job because you'll get paid overtime at the end of the week. Or you might work extra hours because you're not permitted to leave a job site until certain tasks are completed. These examples describe the difference between a positive economic incentive and a negative economic incentive. A positive incentive rewards a person for making a certain choice. A negative incentive punishes a person for making a certain choice. Microeconomics study how people respond to incentives to learn more about the economic choice people make. Why do microeconomics care about the decisions people make? Remember, microeconomics is the study of how buyers and sellers interact. A big part of these interactions is based on incentives. In addition to microeconomics, entrepreneurs rely on this information to help them make decisions about what to produce and how much of it to produce. An entrepreneur is a person who starts and runs a business. Entrepreneurs are important to the economy. All right, somebody read about profit.
An entrepreneur often takes on all the risk involved in running a business. The reward for taking this risk is the profit the entrepreneur may make if the business is successful. Profit is the money a business makes after paying all of its expenses. Profit is the result of successful buyer and seller interactions. Profit is also an incentive for an entrepreneur to do business. Although many businesses work hard to develop innovative and important products, a main goal is making a product.
You just have to read that first paragraph on the next page.
The fact that businesses are mostly free from government regulations to conduct business as they choose means there is no limit to the profits that a business may make. In other types of economies, businesses are under greater government control. There's often debate in the United States over profits and what level of profit is socially acceptable. Some believe that hard work should be rewarded and ultimately benefits all. Others are furious over the sky profits that some companies make, believing they come at the expense of the many.
Okay? So, using primary sources. When you use a primary source, it is important to know and understand the origin of the source. The opinion of the speaker or writer is often clear in a primary source. Pay attention to the tone of the quotation. How would you describe the tone of the quotation? Are they A, they are both content, or B, they are both irritated?
They are both irritated. 180.
Yes, B, they are both irritated. And let me tell you something, Elizabeth Warren made that very clear that she was irritated. Yes. Okay? So somebody else pick up on the back where it says Senator Warren.
Microeconomic concepts. Specialization and interdependence. Both of these contribute to a business potential success. Specialization is focusing on what one does best. This is why because of the school companies also selling factories. Together as an economic specialization improves efficiency. What causes business to specialize? Operating advantages to specialization. A business has a corporate advantage if it has produced something at a lower cost than anyone else. Specialization is the cause of interdependence. Interdependence refers to the idea that the business in an economic are dependent on each other. For example, if you own an ice cream shop, then you make your ice cream. Chances are you do not also own a dairy farm to produce the milk to make the ice cream. You need to buy the milk and other ingredients to make the ice cream. You are therefore dependent on dairy farms and other suppliers. Economic indicators. Microeconomics work economic indicators. These are typical economic data to help you make predictions about the entire economy. You may hear about the economic indicators such as unemployment and inflation reported in the news. They give a good indication of how the economy is doing and where it is headed. One economic indicator is inflation. Inflation is the rise of price related to money and value. If prices rise, but the salary does not, you get less money than you want to. In the United States, the rate of inflation is usually measured using the consumer price index, CPI. The CPI is the representative aspect of goods. The bill of labor statistics is tax of the cost of the goods in prices. The inflation rate is reported as a percentage. If the inflation rate from 2013 to 2014 is 2.5%, it means that the items in the CPI shall 2.5 more in 2014 than in 2013. If the inflation rate is negative, it shows inflation due to the decrease in value relative to money available. Inflation happens rarely compared to inflation. Another economic indicator is unemployment. Unemployment is a measure of the number of unemployed persons in the United States. It is given as a percentage If the unemployment rate is 8.2%, it means that 8.2% of the people in our state who are available for work with a high job. It does not include people who choose not to be in the workforce, like stay-at-home parents or disabled who are unable to work. If the unemployment rate is high, the economy is not good because jobs are being lost inside the place. This means businesses are falling back. If the unemployment rate is low, the economy is growing.
Okay, so compare and contrast. Comparing and contrasting two or more people, events, or things help you understand how things are alike and different. This is true of the article. A, it compares inflation and deflation, or B, it contrasts inflation and deflation. B, it contrasts, so it's telling us what the difference is. Okay? So go ahead and take the rest of class to work on 181 and 183. 182 and 183, I apologize, and then we'll go over it, okay? Step next word, get this
You wish.
Oh my gosh, it's okay. You should have read it up.
You wish.
Oh my gosh. I know, right? Okay. Let's go.
Her name is Kennedy on Instagram. She looks like she just moved over. Okay. But she doesn't make a job. Really? Okay. And it's good quality. No, it looks good. Thank you. I like it. I've had the hair since May. Really? She did it for my birthday first time. And she does the last one every year. So it's an investment. It's not that crazy investment. Like, if you don't get color added to it for like 3 but that's normal. Yeah, it's normal. Yeah. Especially this year.
We did not include it?
She does. I have to pay for everything, but it's like, altogether it's like around, that's normal. Yeah. Unfortunately for women, that's normal. Yeah. Sometimes more too. It's because I had color, so yeah. It was more intense. I know. Talk about them business, so we gotta do all No, see, last time you were grounded, I was like, I hate you. When you guys leave, make sure you sign your name and sign the time you walked in and the time you left. Some of you all left off your name. Ellen, go ahead and sign your name for me, if you don't know. And just put 10:30, 12:30. Thank you, sir. Oh, you did, but you didn't put the time. You get 12:30. Alright, well, you gotta put something in the recycle bin and then we'll go over it. Time and time. Okay. A few people still left. How'd you break that? No longer.
The walls are thin.
Huh?
Walls are thin.
Okay.
Walls really thin.
Oh,
You can't hear it?
I know. Almost. So I can picture once again. We mark once again. It's so nice. Sleepy. Oh, I know. I'm exhausted myself. Well, I'll pray for snow. I mean, I have to be here till Wednesday and Thursday. If the snow is really bad this weekend. It's supposed to start snowing Saturday night. So, hey everyone, do a little snow dance. Okay? Everyone do a snow dance. Yes. Go ahead and get my little stuff so I can plan to be in the house. And my baby just just hurts when I wake up and there's nothing on the ground. Why?
I haven't
just
seen
knew I
snow
was gonna have a
like
few days.
since I lived up north. That was
A few days that I don't have to be responsible.
2014.
I don't have to sit on the couch.
That was in Madison, Wisconsin, of all places.
Sleep on me that. Just come over it. I know that you guys got a little early. for the director to have. And then I normally let you guys go a few minutes early, but the director will go tomorrow.
Quadratic equations in there. They're doing quadratic equations.
Yeah.
I hate that crap. Comparative advantage.
Say it again? Yes, a cooperative advantage. Alright, number 2, a blank is a person who starts and runs a business. Yes, entrepreneur. Number 3, business and companies around the world are connected due to their interdependence. Alright? People make decisions based on incentives. Blank is the amount of money a business has left over after its expenses. Profit. Businesses focusing on what they do best is specialization. Alright? How do views expressed by Ayn Rand and Elizabeth Warren in the quotes differ? How do their opinions differ?
Rand believes people should not share their profits, whereas Warren believes people should give some profit to others.
Absolutely. Perfectly said. All right, number 8. How is a positive incentive different from a negative incentive?
A positive incentive is when a person is rewarded for making a choice. A negative incentive is when a person is punished for making a choice.
Exactly. So another real-world example is getting your hours cut at work is a negative incentive. Being able to work overtime, positive incentive. Okay? Number 9. Is a person who is not looking for a job part of the unemployment persons count to determine the unemployment rate?
No.
No. And why? Yep, they're not the ones seeking jobs. Okay, number 10. Suppose you create a line graph by plotting the unemployment rate on the x-axis and the number of people who are unemployed on the y-axis, which best describes how the two are related. A, B, C, or D?
A.
A. The number of people who are unemployed increases, so does the unemployment rate. It increases as well. Number 11. Which cause and effect relationship is true about economics?
A.
Not A.
C.
C. Specialization leads to interdependence. Alright, number 12. Country X takes 10 years of labor to produce wheat and 20 years of labor to produce corn. In country Y, it takes 20 hours of labor to produce wheat and 10 hours of labor to produce corn. According to the idea of cooperative advantage, which country should produce wheat?
C.
C. Country X. Alright? Number 13. What aspect of entrepreneurship appeals to you? So why would you want to go out and start your own business?
Freedom to choose and possibility of profit.
Freedom to choose and possibility of profit. I think that's one big thing for everybody. What else? Why would you want to start your own business? To make your own profit. I would want to do it to do something I love every day. I love coming in here and teaching you guys. I really do. My first love was teaching. My second love is mental health stuff. So when I'm able to open up my mental health clinic, I will be going to work doing something like I've invested in for the rest of my life. But it's good that I have the best of both worlds while I'm trying to get that up and started and doing this. So y'all fulfill me. What's another thing that we would like to do and why we want to have our own business? What else?
You would be the boss, basically.
You would be the boss. There's no one telling you, hey, you can't have this day off like you request it. You make your own schedule. You're flexible. You can work from home. Hey, you can work from Aruba if you want to. It's on you. You're the boss, right? Exactly. All right, so what effects will a high rate of inflation likely have on a small business?
Their employees would be paid less.
Yes, their employees will be paid less, and what else about their product?
Is it something to do with taxes?
Yes, they have to pay more taxes. And let's say if you have a small Dunkin' Donuts, but a Kia Donuts, I'm going to have to make sure I charge my customers more for my donuts because I don't have any overhead yet. So that's another thing. So small businesses would definitely hurt if inflation went up because at the end of the day...
Well, it's already gone up like
Yeah,
quite a
it's
bit.
already gone. So basically they're in a deficit coming in the door. Yep. All right, guys, so that is it. Y'all have a safe, long weekend. Remember to do your